Today, we're going to be starting a new chapter. This is going to be chapter 4, and this section is primarily focusing on what atoms are. We're going to be taking a look at how big an atom is, or its size. We're going to be taking a look at the contents on the inside of an atom. We're going to be taking a look at what are called the subatomic particles, and then we'll take a look also at the periodic table. So please copy this information into your lecture notes. So we're starting with a new chapter, a new section. This is going to be section 4.1. This is going to be taking a look at atoms. So we're first going to take a look at how large an atom is. If you take a meter stick, okay, so the meter stick that I have here in the front of the room, okay, here we go, the meter stick, okay, that's where we're going to be starting with our frame of reference. So the size, we have 1 meter. If you take that meter stick now and divide it into 1,000 little parts, you get each one of these little measurements, which is going to be a millimeter, if you remember that from the previous chapter, chapter 2, I think it was, when we looked at measurements. So if you take this 1 meter and divide it by 1,000, you now have 1 millimeter. And a millimeter is about the size of a dot. Okay, so here's our dot. If you take this dot and then you divide this dot by about 10 million, so divide by 10 million. That's about how large an atom is. Meaning, in this dot, you can probably fit 10 million atoms side by side to make that dot. So it's important to know the size of atoms. Atoms are incredibly small. They're about 10 million times smaller than a dot. In chemistry, we take a look in more detail to see the actual size. So that's how big an atom is. We're also going to take a look at the structure of an atom. So that's what this section is going to be looking at. What's on the inside of an atom? And we're going to take a look at not just the structure defined, but also the charge of those things that you find on the inside of an atom, and where do you find them? And it's the location. So we're going to take a look at these 3 parts to the atom. What are their charges, and where are they found? So there's 3 parts to an atom. We have these particles that are called protons. And we'll draw this in a little bit. We also have these particles called neutrons. And we're going to be building an atom as part of our lab activity. And then you're also going to have these particles called electrons. So we have the whole atom. Now, this is broken down into these 3 parts of the atom. So we have these 3 parts, or these 3 pieces of the atom. We have protons, neutrons, and electrons. So these 3 particles have a very particular name, and they're called subatomic particles. Subatomic particles. The reason why they're called subatomic particles is because sub means below, like a submarine. Where do you find a submarine? You find it below the marine environment. Okay? You have the way that you may commute on the street. Then you also have a subway, and the subway is below the street. So your atom is the structure, and you have these three smaller parts to that structure, and those are called subatomic particles because they are below the atomic level. So you have your atomic level, 10 million fit inside of this, but in one of those little atoms you have these three pieces or these three parts. The charges of these, pro, if you're pro something, you are for it. You're pro-war, for example. You want war. So this would be positive. And we also have these other particles, subatomic particles. They're called neutrons. Okay, neutron sounds like neutral. Well, like Switzerland during the World Wars, they maintained neutrality. So they have a zero charge. They're neither positive nor are they negative. And an atom has to be balanced with its charge, meaning it has to have the same number of positives and same number of negatives. So those negatives are going to be what are called the electrons. So your positive particles are your protons, your negative particles are the electrons, and your neutrons are going to be neutral or zero charge. Here is the symbol for these as well. We abbreviate protons with a P, capital P, and we usually put a plus to them. The neutrons is a capital N, and it's going to have a 0. And electrons are going to be a lowercase e with a minus. Where do you find these? You find the protons and neutrons in the center of the atom, and we'll draw this in just a minute. And the center of the atom is called the nucleus. Where do you find the electrons? The electrons are outside that nucleus, and they go around the nucleus in what are called shells or electron shells. Again, we'll be doing all this in the lab to get a little more familiarized. But let me show you what helium looks like. So here is the element for helium. Okay, helium has the symbol on the periodic table, and it is He. And helium has 2 protons. So I'm going to draw a proton here and a proton here. It has 2 protons. It has 2 neutrons. And again, these are together inside the nucleus. They're in the center of the atom. And then surrounding that are going to be the electrons. And the electrons will be circling about the nucleus, which is the center, in what are called the shells. So again, the protons and the neutrons, these are inside the nucleus. The nucleus is the center, and the electrons are going about the outside of the atom in what are called the shells. So this shows the structure of an atom. This is one atom of helium, and we can see our 3 subatomic particles, our protons with a positive charge, our neutrons with a neutral charge or no charge, located in the nucleus, surrounded by the electrons that have a negative charge, and those occur in what are called the electron shells. And I mentioned earlier that an atom must be neutral. That's the definition of an atom. So an atoms are neutral. So what must they have to have in order for them to be neutral? Well, take a look at the charges. The neutrons really don't play any part in the charge, but we have 2 positives, 1, 2, and we have 2 negatives, 1, 2. So because an atom is neutral, the number of protons are going to be the same as the number of electrons. The number of positives must be the same as the number of negatives.